Welcome to section 1.2, which we are going to be talking about inductive reasoning. Inductive reasoning is when you make a conclusion based on a pattern of examples or past experiences. So, what is a conjecture? A conjecture is an unproven statement based on a pattern or observation. It's basically an educated guess, so it's kind of like a hypothesis. So inductive reasoning, like we said on the previous slide, is when you make a conclusion based on a pattern of examples or past experiences. Okay, so in order to prove a conjecture false, we just need to find one counterexample. And a counterexample is an example that shows a conjecture to be false. So for example, if I have a classroom of sophomores and I make the conjecture that every student is 16 years old, a counterexample would be one student who is actually 17 years old. And we would just need one counterexample to prove the conjecture false. Okay, so like I said, a conjecture, it's like an educated guess, sort of like a hypothesis. Okay, so complete this conjecture. The sum of any two odd numbers is, so let's add together two odd numbers like 1 plus 3, and we get 4. So 4 is an even number. Let's just add together two more odd numbers just to make sure, and we get 8. So the sum of any two odd numbers is going to be even. The product, remember, sum means addition, product means multiplication. So the product of any two odd numbers, so if I take two odd numbers and multiply them together, I'm going to get what type of number. So if you look at these examples, we take two odd numbers, multiply them together, and all of our products are odd. Difference means subtraction. Divisible means division. And just a reminder that integer means a whole number, so not a fraction. And we can have positive integers like 1, 2, 3, 4, 5. We can have negative integers like -1, -2, -3, -4, -5. So in order to prove that a conjecture is true, you have to prove it true for all cases. But in order to prove it false, you need to find a counterexample. That just means you only need one counterexample to prove a conjecture is false. So a counterexample is an example that shows a conjecture is false. So like I said, if you make the conjecture that a classroom full of sophomores, every student is 16 years old, a counterexample would be a student who is 17 years old. So for example, the sum of two numbers is always greater than the larger of the two numbers. So sum means addition. So if I take two numbers and add them together, we're going to get a sum. And the conjecture is that the sum is always greater than the larger number. So let's say this is the larger number, this is the smaller number. When you're trying to find a counterexample, you want to kind of think outside of the box. And the way that you can do that is by considering negatives and by considering 0. So let's think of two numbers that when we add them together, the sum is less than the larger number, because that will break our conjecture. Okay, if we take any two odd numbers, like -4, sorry, not odd numbers. If we take any two negative numbers, like -4 and -5, and add them together, that's going to give me a sum of -9. Well, -9 is not greater than the larger number of -5. And actually, let me back up a second, because -5 is not larger than -4. Let's switch these around. -5 plus -4. -4 is larger. So -9, the sum, is not greater than our larger number, -4. So we found an example that proved our conjecture false. Right? It breaks our conjecture. So the next example, if the product, meaning multiplication, of two numbers is positive, so if I take two numbers and multiply them, they're saying if it's positive, then these two numbers that we multiplied together must both be positive. So they're saying we have to multiply a positive by a positive to get a positive. But that's not true. We can come up with a counterexample. We actually can multiply a negative by a negative to give us a positive. So -2 times -1 is a counterexample because it breaks my conjecture. Right? It means that my conjecture is false. If the product of two numbers is even, then those two numbers must be even. So if I multiply two numbers together and I get an even product, then they're saying that these two numbers must be even. But that's not true. I can multiply 2 times 3, so an even times an odd, and it will still give me an even product. For example, 6. So again, don't forget to consider negatives and the number 0 when you are trying to find counter examples. You only need one counter example to prove that your conjecture is false.